In previous videos, I've taught you about the product rule and the quotient rule. In this video, I will teach you one more fundamental derivative tool called the chain rule. If you appreciate the content, please give it a like. You're going to need the chain rule when you have a function that's inside of another function. In this case, the outer function was x to the 10th power, and the inner function 3x minus 4 is being plugged into it. This one is less obvious, but we can think of the outer function as 2 over x, and the inner function x squared plus 6 has been plugged into that. To solve a problem like this, the first thing we would do is rewrite it by bringing the denominator up to the same level as the numerator with a -1 exponent. In this form, it's more obvious that we have this inner function x squared plus 6 and then this outer function 2x to the -1 power. We would need the chain rule on this one because we have this outer function cosecant and then the inner function of 2x. Trig functions are usually pretty obvious when we need the chain rule. If there's anything inside the trig function other than just an x, we're going to need the chain rule. Of course, the outer function is the tangent function, and the inner function is the x plus 4x squared. The chain rule basically says that when you have a function inside of a function, you can take the derivative by first taking the derivative of the outer function, and then multiplying that by the derivative of the inner function. The chain rule looks a little bit different depending on whether you have the Leibniz notation or the Lagrange notation. But let's start with the Leibniz. If we call the inner function u, then the derivative of the outer function will be dy du, the derivative of the function with respect to the inner function. And the derivative of the inner function, since we're calling the inner function u, will be the derivative of u with respect to x. For example, if y equals the sine of x to the 3rd power, we have this function inside of another function. Let's call the inner function u. So u equals x to the 3rd power. So we can think of y as the sine of u. According to the chain rule, y prime will equal dy du times du dx, the derivative of the outer function times the derivative of the inner function. The outer function is the sine function, and the derivative of sine is cosine. That's a memorized rule. So we have the cosine. We are taking the derivative with respect to u. So for now, we leave the u in there. But then we multiply by the derivative of u with respect to x. We suddenly remember that u is x to the 3rd power. So the derivative of u with respect to x is going to be 3x squared. Substituting the x to the 3rd power back in for u gives us the final answer. Y prime is equal to the cosine of x to the 3rd power times 3x squared. Now in practice, we don't really do this u substitution. We just take the derivative of the outer function, keeping the inner function the same, and then we multiply by the derivative of that inner function. And that's the chain rule. The chain rule feels a little bit more straightforward in the Lagrange notation. So here, f is the outer function, g is the inner function. According to the chain rule, we first take the derivative of the outer function, so I'm just going to put f prime in blue. When you do the chain rule, when you take the derivative of the outer function, you leave the inner function unchanged, but then you multiply by the derivative of that inner function. But here, when you do the derivative of the outer function, leave the inner function as it was. Let's redo this example without the u substitution. According to the chain rule, we take the derivative of the outer function, and sine becomes cosine. We keep the inner function the same until we then multiply by the derivative of the inner function, which is 3x squared. And that's really all there is to the chain rule. Pause the video and see if you can work out this first example by yourself. I've colored the outer function in blue and the inner function in red. According to the chain rule, we first take the derivative of the outer function. So, using the power rule, the 10 is going to go to the front, and the exponent is reduced by 1. As you do the chain rule, when you take the derivative of the outer function, you leave the inner function the same. But then you multiply by the derivative of the inner function, which is simply 3. This is a perfectly good answer for a free response question, but it feels silly not to multiply the 3 times the 10. So a slightly more simplified answer would be 30 times 3x minus 4 to the 9th power. Pause the video, try this one. Students will often use the quotient rule on a problem like this, which is not wrong, but it's the long way and they usually make a mistake. My recommendation is, if the numerator is just a constant, or if the denominator is just a constant, do it without using the quotient rule. When the numerator is just a constant, you can bring the denominator out to the side with a quick rewrite and put a -1 power. Now we can use the chain rule, which says we can take the derivative by first doing the derivative of the outer function, the blue function. So I'm going to take this -1 and multiply by the front. So we have -2. And then we reduce the exponent by 1, so this becomes -2. The inner function stays the same at this moment, but then we multiply by the derivative of the inner function, which is 2x. This is a full credit answer, but if we do simplify, we're going to multiply these together. So we're going to have -4x times x squared plus 6 to the -2 power. So that's for sure a full credit answer. But on a multiple choice question, you might also see it written this way. With that negative exponent, this can drop down to the denominator and be written as x squared plus 6 squared. So there's 3 different versions of the answer for you. As soon as we see a function inside of another function, we know we're going to have to do the chain rule. So first we take the derivative of the outer function, and this is just a memorized rule. The derivative of cosecant is negative cosecant cotangent. So you have to write the parentheses twice. At this moment, the inner function stays the same. So inside the parentheses, I just have the 2x. But then we multiply by the derivative of the inner function, which is just 2. On a multiple choice question, you will likely see the 2 in the front like this. I've colorized the outer function in blue and the inner function in red. Chain rule says, first you take the derivative of the outer function. Memorized rule, the derivative of tangent is secant squared. So we begin by writing secant squared parentheses. And inside the parentheses, we keep the inner function the same, x plus 4x squared. But then, step 2, we multiply by the derivative of this inner function. This time the derivative will have more than one term, so we're going to need parentheses. The derivative of x is 1, and the derivative of 4x squared is 8x. And that's it. F of g with an open circle like this means composite. So it really means f at g with g as the inner function. And according to the chain rule, when you take the derivative of a function inside of a function, first you take the derivative of the outer function and you keep the inner function the same. But then, step 2, you multiply by the derivative of the inner function. So there's your chain rule. Looking at this example, the outer function is the to the 7th power part. So according to the chain rule, we take the derivative of the outer function, which I've shown here in blue. That's the derivative of the outer. The inner function is the sine x. In step 1, as you take the derivative of the outer function, you keep the inner function the same, until step 2, when you multiply by the derivative of the inner function. The derivative of sine x is cosine x. So that's the answer to this example. The students will often get confused with trig expressions when exponents are involved. These two expressions do not mean the same thing. When the exponent is on the end like this, it automatically means that the exponent only pertains to the x. In other words, the x squared is inside the function. The whole function is not being squared, just the x. So, written the first way, it means this. Sine is the outer function, x squared is the inner function. If the whole function is to be squared, meaning sine x times sine x, that's when you put the exponent in the middle like this. So y equals sine squared x means sine x, whole thing, is being squared. So it's the reverse of what we saw before. This time, sine x is the inner function, and the squared part is the outer function. Either way, we are going to need the chain rule. Back to this example. According to the chain rule, we first take the derivative of the outer function. The derivative of sine is cosine. As you take the derivative of the outer function, you leave the inner function alone. But then step 2, you multiply by the derivative of that inner function. So that's the answer. On a multiple choice question, you will likely see the 2 in the front like this. So I'm going to model that for you. To the other example, first we take the derivative of the outer function. So this 2 is going to come to the front, and reducing the exponent by 1, this is an invisible 1. As you take the derivative of the outer function, you leave the inner function alone. But then, step 2, you multiply by the derivative of the inner function. The derivative of sine x, again, is cosine x. So that's the answer. Written without parentheses, 2 sine x cosine x. Isn't this one of our double angle identities? On a multiple choice question, you might see it written like this. Because this happens to be this double angle identity. But to be clear, on a free response question, this is a perfectly valid answer, and I wouldn't even risk trying to write it as the double angle identity. Just stop here. Sometimes you have a function inside of a function inside of a function, and you have to do the chain rule more than once. First, you take the derivative of the outermost function, so I'm putting f prime, leave the part inside the same, but then you multiply by the derivative of the next function on the inside, so I'm going to say g prime. You leave the part on the inside the same, but then you multiply by the derivative of that inner function. So sometimes you have to do the chain rule 2 or more times. That's exactly what we have on this example. We have a function inside of a function inside of a function. Tangent is the outer function, and then inside of that we have something squared, and then inside of that we have the pi x. So according to the chain rule, to find the derivative, first we take the derivative of the outermost function. Memorized rule, the derivative of tangent is secant squared. We keep what's inside the same. I don't like to put parentheses inside of parentheses, so I'm going to use brackets. This is just me. You can just use 2 sets of parentheses. Anyways, we have secant squared, and then inside of that we have the inside part hasn't changed yet. Now we multiply by the derivative of the inside part. But we're going to need the chain rule to take the derivative of the red and the purple. At this level, we take the derivative of the outer function, which is the red. So we move that 2 to the front. The purple stays the same, but then we multiply by the derivative of the purple. The derivative of pi x is pi. So this is the answer. Remember, when the 2 is in the middle like this, it means the entire thing is being squared. So the exponent, the 2, is the outer function. So as I sort of colorize this, the whole thing is being squared. And then inside of that, we have tangent. And then inside of tangent, we have the pi x. So according to the chain rule, to take the derivative, first we take the derivative of the outermost function. So the 2 is going to come here to the front. Whatever you have on the inside stays the same. So we have the tangent and then the pi x. But then we multiply by the derivative of the inside part. Here comes the chain rule again. Because as we take the derivative of the red and the purple, we start with the outer function, which is the red. And the derivative of tangent is secant squared. At this stage, we leave the purple the same until we then multiply by the derivative of the purple, which is pi. So this is the answer to this one. This one is going to blow your mind because we need to use a combination of the product rule and the chain rule. So the first thing we see is we have the product of what I'm going to color yellow. All right, we've got this yellow function times this blue function. So we're definitely going to have to do the product rule because of that product. But then when we get to the blue function, that one is a function inside of a function. So we'll need the chain rule to deal with that when it comes. But first, the product rule. Do I have space if I write small? According to the product rule, we go through it twice. The first time through, we take the derivative of the yellow. I think I'm going to do it down here where I know I'm going to have space. The derivative of the yellow, power rule, the 4 comes to the front, multiplies the 6, so we've got 24. Reduce the exponent, 24x to the third power. The first time through, you leave the second function alone, unchanged. So x squared minus x to the 9th power. And then you put a plus and you go through it again. The second time through, you leave the first function unchanged, 6x to the 4th power. But now it's time to multiply by the derivative of the second function. This is going to require the chain rule. So we start by taking the derivative of the outer function, which means moving this 9 to the front and reducing the exponent by 1. At this level, you leave the inner part the same. So we have our x squared minus x, but then you multiply by the derivative of the inner function, which is 2x minus 1. So that is the answer. Ooh, let's do one more. Here's a hint. It's going to require the quotient rule. So pause the video and try this one by yourself. First, we take the derivative of the outermost function, which means taking this 2 and bringing it to the front. Reducing the exponent by 1 just leaves a 1. As you take the derivative of an outer function, you leave the inner function alone. But then you have to multiply by the derivative of the inner function. Well, this is going to require the quotient rule. And the poem for the quotient rule goes low d high, less high d low. Draw the line, and down below, the bottom squared will go. So I'm going to go ahead and do that bottom squared part of the poem. While it's fresh in my mind, the bottom squared will go. So now I just need low D high less high D low. What does that mean? When I say low, it means the denominator. So I'm going to write secant x minus 5, and it has to be in parentheses. In fact, maybe I don't need these parentheses because the division bar is its own grouping symbol. So that's low. When I say D high, I mean the derivative of the numerator. The derivative of 2x is 2. So that's low D high. Less means subtraction. And then high D low. High means record the numerator. And then D low is the derivative of the denominator. Memorized rule here. The derivative of secant x is secant x tangent x. So we're going to have secant x tangent x. The derivative of a constant is 0, so that's really it. So this was low D high less high D low. Draw the line, and down below the bottom squared will go. So hey guys, that's it. That's the whole thing. Just for fun, I'm going to simplify this a little bit. If this was a free response question on a test, leave your answer like this. Do not risk making a mistake in the simplification process if you don't have to. But just in case, this would be like a multiple choice question, or sometimes we have to go on and, find the location of a horizontal tangent line or something like that. So sometimes you have to simplify in order to move forward with the problem. Resist the temptation to cancel out the secant x minus 5 that's here against one of these that's down here. This is connected by subtraction. You cannot cancel out things that are connected by addition or subtraction. So do not make that mistake. Having said that, we have these two fractions, and when you multiply, you sort of multiply straight across. So ultimately, the secant x minus 5 times secant x minus 5 squared will become secant x minus 5 to the third power on the next step. I made a couple other cosmetic changes. 2 times 2x is 4x, and I noticed that both of these terms had a common factor of 2. So I went ahead and pulled the 2 out in front of that so that on the next step I could multiply this 2 times the 4x. So here's a slightly simplified version of y prime, but again, on a test, please stop here. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.